In today's video, here is a nice problem. It's coming from Bulgarian Mathematics Olympiad edition 1975. Here is the following setup. So our goal, we are going to prove this number, which is 2 to the 147 minus number 1, is divisible by 343. Okay, so we are going to do it in two different ways. So the first way, we are going to apply the lifting exponent lemma. The second one, we are going to do the classic one. Okay, so by the way, don't forget to hit the subscribe button and support the channel. So now let's go ahead, jump into the solution. Okay, in fact, it's a very beautiful method. It's called lifting exponent lemma. So this one, it's more quicker. So for the prime p, we have x to the n minus y to the n, which equals vp, the difference of this basis x minus y, plus vp of the exponent n. Okay, so the lifting exponent, we are dealing with the exponent of the integer. Okay, so we must have the same exponent n. So here we have to have this difference. So the condition to apply this theorem, you should have p divides as a prime, p must be odd prime, divide this difference x minus y. P is an odd prime. This is the most important thing. We have to have this condition, then we apply this theorem. So we can have also plus sign here, and then also we can have a p as an even prime. So for our example, we are going to choose the p as an odd prime. Okay, now it's more simple. We are going to know now the purpose of this one. We are going to look for the largest power for factorization prime for this one. Okay, we are going to look for this one. This number 247 minus 1 is going to be, which is this one, like for example minus to the 1 minus 47 is going to be written as 7 cubed, which is 343 factor something. This is our goal. So if we are able to find this one, that's mean we have done with this problem, because this term will be divisible by this one equals to integer. This one is an integer. Okay, so we need to write this one on this form, but the problem, be careful here, we need to extract this one, we need to know this one. That's problem. This difference is not satisfied this condition, because if you take 2 as a x and number 1 as a y, you take in this difference is not going to give us up this one, which means we are going to transfer this expression into another expression where we have this condition. Okay, it's more simple. 247 is going to be written on this form. 3 is multiplied by 49 minus number 1, which equals 2 to the 3, all is raised to 49 minus 1, which equals 8 to 49 minus 1 to 49. Now we have transferred this one into this one. Exactly. Now we have p. Now the difference x minus y is 8 minus 1, 7. 7 is a prime, which means 7. Now this one, 7 divides 8 minus 1. Okay. Now we are going to do the same thing as I have here. Let's replace everything with are taking this one, which is 8 to the 49 minus 1 to the 49, because this one equivalent to this one. Okay, which means v of 7 of this difference, which is 8 minus 1, plus this lifting exponent is 49. 49 is the same 7 square. Okay, this 8 minus 1 equals 7 to the 1. So we are going to select only the exponents. We have the sum of this exponent, this one, we have number 1 plus number 2, which is 3. Now we are going to express this one. Now we are going to express this one on this form. So we get 2 to the 147 minus 1 to the 147, which equals this prime 7. We get, this is what I was looking for this exponent 3. Factor something. We don't care about this number which left. We care only about this term product, because this one, it will be divisible by this one, is going to give us an integer, which means we are proving this one. Okay. Now this is more powerful method. Now we have applied very quick method. Now let's move on to the classic method. Now let's move on to the second method. So keep in mind, in the second method we are going to apply the Euler theorem, but before we apply Euler theorem, we are going to make some exploration here. We are going to check what's another alternative expression for this one. So we know 2 to the 2 cubed, which 8 equals 2 cubed, which is congruent to 1 mod 7. Okay, it's more clear, this one. Then we are going to raise this exponent to 24. This one will equivalent 2 to 72, which is a congruent to 1 mod 7. Okay. Also, then raise number 2 as a power again. Okay. I will achieve the following value: 2 to the 144 is a congruent to 1 mod 7. Okay. Then multiplying both sides by 8. So if I'm going to do that, I will have 2 to the 3 is multiplied by this one, is going to give us 2 to 147, which is a congruent to 8, which is a congruent to 1 mod 7, because we have 8 is 1 more than 7. Okay. Then I'm going to see this one for later as an original statement. Then we are going to check the other side of the proof. This is the right time where we can apply the Euler theorem. Okay. According to the master Euler, so we have phi of n equals n factor 1 minus 1 over p1 and all the way down to the 1 minus 1 over pk. Okay. Which condition we can have for this one? We must keep GCD of equals 1. We must have this condition first. So 2 to the phi of 343 is a congruent to 1 mod n, which is 343. Okay. So we need to calculate this one. Phi of 343, I'm going to apply this product. Okay. So replacing n with 343 here, replacing this one over p1 with number 7, because 343 has only one prime, which is divisible by 343, which is number 7. Okay. So this one is going to give us 294. Okay. So I'm simply going to replace this phi of 343 with 294. Okay. So now we get 2 to the 94 is a congruent to 1 mod 343. So the next thing up, now we are going to make this one on this form. Simply we are going to take the square root on both sides. I'm going to take square root on both sides. I will have two things here, two statements. I will have 247 is a congruent to 1 mod 343, or 2 to the 147 is a congruent to minus 1 mod 343. Okay. But the problem, we don't know which one is right, which one is wrong. Okay. So we need to prove one of these. We need to force one of these must be out of this possibility. Okay. So we need to force this one. So since this one, it looks like the same as I have previously proven, which is this one. Okay. So, but the only difference between first statement and this one, the only difference between the first statement and this statement, this one has a divisor number 7, this has a divisor 343. This one is more powerful than this one. For up to here, we cannot say this one is divisible by 343 because we know only this one is verifying 7 divides this difference, this one minus number 1. But this one is saying this difference is divisible by 343 in case if you are going to take this one out of here. Okay, let's get these two statements at the top and continue with the proof. So by the way of contradiction, suppose this statement is true. Okay, now if we assume this one is true, I'm going to take this minus 1 to the left side. I will have 2 to the 147 plus number 1 is a congruent to 0 mod 343. Okay, this one is telling us, this one immediately is going to tell us 343 divides this sum, which is 2 to the 147 plus number 1. So since this big number, since this 343 equals 7 cubed, okay, if 7 cubed divides this one, is automatically 7 is going to divide this one because this one is bigger than this one. Bigger number divides this number. What about smaller number, which is a multiple of this one? Is absolutely going to be divisible by this one. Okay, so this one is telling us 7 divides 2 to the 147 plus number 1. According to the divisibility statement, we get 2 to the 147 is a congruent to minus 1 mod 7. Okay, 2 to 147 is a congruent to 1 mod 7. Also, this 2 to 147 is a congruent to minus 1 mod 7. Okay, so if I'm going to put them together, I get 247 is a congruent to 1. The other one is a congruent to minus 1 mod 7. Okay, taking this minus 1 to the left, I get number 2 is a congruent to 0 mod 7. According to the divisibility statement, 7 divides 2. It's a contradiction. Okay, impossible. What does mean impossible? Which means this one will be wrong. We are taking only this one, which means is our proof. And thank you for watching. I will see you next video. Bye.